Good morning. Welcome to reInvent Day 3. Who's excited to be here? Awesome. So show of hands, who out in the crowd is multi-cloud today in your business? Who's multi-cloud? Okay, so we have a lot of them. So you're in luck. So today you're going to hear about a real life multi-cloud story with a real customer, a real CTO telling you about their process to go through it. Good morning, my name is Rusty Grayson. I'm an AWS account principal, and I will be one of the ones presenting to you today. Here's a quick look at our agenda. After telling us about Crane Worldwide, $1 billion plus third-party logistics company, Brandon Kirkendall, Chief Technology Officer from Crane, will give you a behind-the-scenes look at the strategy behind his organization's move to AWS. Akil Melakunta, my colleague, AWS Senior Solutions Architect, will provide a deep dive into how a joint team thought or brought Brandon's vision to reality. We'll finish off the session with some innovations that Crane is bringing to their business with agentic AI and satellite communications. So nobody likes cloud migration stories that start off with digital transformation. So we're not going to do that today. And nobody likes 17 bullet points on a slide that nobody's going to read anyway. So we're not going to do that either. So let me tell you what happened. Crane Worldwide, big logistics company, moving stuff all over the world. And they were spending money on cloud infrastructure that was not a valuable asset for them. So they moved to AWS as their primary cloud platform. And when they did, they saved money, they got faster, and they got more agile as well. So you may be thinking, Rusty, what is this, another cost-cutting story where they fired a bunch of people and turned off the lights? That's not what we're going to talk about today. Because Crane got faster, and they got more scalable, and they're using satellites and AI. So that's what you're about to hear, and you're not going to hear about it from me. You're going to hear about it from Brandon, the CTO who actually did the work. So here's the thing about logistics, and I know this because I asked them and they told me. Logistics is hard. You've got ships, trucks, planes, warehouses all over the world, and everybody wants to know where their stuff is right now. Not in 5 minutes, they want to know now. And if Crane's technology can't tell them, those customers are going to go elsewhere. So here's where it gets interesting, and we'll go over most of this in the session today. Crane made AWS their primary cloud, and that's important. Primary means most of their workloads, most of their innovation, and most of their investment in technology is now going to AWS. But, and this is the real world talking, they still operate in a multi-cloud environment. Some stuff runs on Azure, some on OCI. Why? Because that's how real enterprises work. You've got acquisitions, you've got vendor requirements, you've got applications that aren't worth moving. At least not yet. And you know what? That's okay. The story today here is not about cloud religion. It's about making AWS the engine that drives your business forward while being smart about the rest. So here's specifically what Crane did with AWS. First off, cost optimization. Real cost optimization where they reinvested savings into modernization and AI and into satellites. Scale. Crane can now deploy applications anywhere in their network without rebuilding everything, and we'll show you what that looks like on AWS today. AI. And a little hint, not the type of AI that you ask to write a poem. AI that optimizes supply chains and predicts problems before they even occur. And finally, Amazon Leo, Amazon's satellite network, which means Crane can now operate in places where the internet doesn't really exist today, in the middle of nowhere. So what are you going to learn today in the next 50 minutes in this session? You're going to learn 4 things. Number 1, how to migrate. The real story, not the sanitized version. How Crane and AWS moved as AWS as their primary cloud platform while keeping the other clouds operational. How they kept the business running when they ripped out the foundation and built it again. 2, how to optimize. What architectural decisions did Brandon's team make? What did they stop doing that they thought they needed to keep doing? And here's the practical part. How do you optimize in a multi-cloud environment? 3, modernize. Containerization, serverless, but more importantly, how they got legacy applications that people said were unmovable, and they moved them to AWS anyway, where they could actually do something with them. And last, innovation. The AI implementations, we'll talk about that during this session. The satellite part from Leo, we'll talk about this in this session. Most companies won't be here for another 2 years. Crane is there today, and they're going to tell you what it's actually like. So with that, I'd like to introduce you to Brandon Kirkendall, Crane Worldwide's Chief Technology Officer. Brandon?
Thanks, Rusty. Oh, thanks. Okay, so let's start with who is Crane, because most of you guys probably never heard of us. We're a 3PL, about a $3 billion company that moves goods around the world. We're headquartered in Houston, Texas. We were founded in 2008, so a fairly young company. We have over 150 offices in 30 plus countries around the world, about 4,000 employees. We're privately held, so we're very entrepreneurial as a company. We move fast, very, very fast, and we use that as a competitive advantage. How does that play into why AWS and why did we embark on this journey? It was never about cost, although we definitely want to be cost conscious. It was about fueling the pace of innovation. We have to be able to move faster and faster with more certainty and a very, very secure, reliable, and scalable infrastructure. So that's what our aim and our goal was. So why AWS? Because their DNA is a lot like ours. They're very, very entrepreneurial. They like to move fast as well. And they bring resources and partner with you, at least for us, in a way that we had not seen with other providers. So for Crane, we're customer obsessed, a lot like AWS. Our core values are integrity, innovation, execution, partnership, and ultimately results. That's how we measure everything, is in results. Okay, so I'll tell you guys a little bit about the logistics landscape. Most of you guys probably aren't super familiar with it. I have to thank our friends at Amazon for really changing the game and making my job a lot more difficult because we constantly get the question of, well, Amazon can tell me when a package is on my porch. Why can't you tell me, right? So thanks a lot for changing the game. Well, ours is a little bit more complicated. So we deal with multiple modes of transport, right? We're talking about air, ocean, ground transportation. We have warehouses all over the world. We have to deal with the complexities of tariff changes, customs compliance, customs declarations, all the way down to sometimes partnering with our clients to help them understand what materials are actually in the goods that they're moving so that we can properly clear customs. So as you can see, there's a lot of documentation. There's documents, more documents. So where our take on AI, at least for now, is that it's best when there's a human in the loop. So a lot of what you'll hear from us is deploying LLMs to keep our logistics professionals in the loop, make them more agile, ultimately faster, and provide better service for our clients. We also have to track in real time GPS throughout the world. So a lot of data, right? And we have to have an infrastructure that can handle that, especially in peak load times, right? If you looked at our business, there is a peak, and our volumes can sometimes go up 10x. So we have to be able to handle it every day and scale to manage peak load. Customs and tariffs. Thank you, Trump administration, for making this much, much more difficult for everybody around the globe. But it did create an opportunity for a lot of people to really stand out and shine. So what we have to do there is navigate a growing, complex network of tariffs, customs regulations, and filing appropriately to keep goods moving. Cost optimization. When I say that, don't think cloud cost optimization. Optimizing costs for our clients, how we actually move their goods throughout the world, and how we can save them money, most of all time, and predict and hit our service SLAs. Which brings us to the forecasting bit, right? So Rusty's right. People don't want to just know where are my things now. They want to know, well, what is going to impact how my goods move 3 months from now, 6 months from now? What are rates going to be? Is there going to be political instability that we should be on the lookout for? Are there port strikes that could impact the goods that we need to move? So a lot of complexity. So our migration strategy, what were we really trying to hit? Provide rapid value to our clients. We need to be able to move fast. In order to be able to move fast, we need to have an environment that we can rely on. From a deployment standpoint, eliminate click ops and human intervention and make things as repeatable and consistent as possible. That should help accelerate our AI outcomes, because without being able to move quickly, experiment, and ingest volumes of data, you really limit yourself from what you can do from an agentic standpoint. And then be ready for growth in the future. Obviously, all of this has to be in a secure, resilient, and reliable environment. So success factors for me, we had to make absolutely certain that we could deploy via code. We took an engineering first approach to everything that we did during this migration to create reliability. We had to be able to be in multiple regions for scalability and redundancy, for business continuity. And then where we could, how do we modernize? Not just lift and shift, right? Where could we actually take a look and see where we could use serverless options, where we could reduce some of the complexity and simplify our environment? The execution team. So we had a lot of expertise in other clouds, but not a lot with AWS, not to the same level that we did with other providers. So when we started, I made it very clear to our partners at AWS that we were going to need not only training, which they put together a tailored training plan just for our staff, but then we also wanted to take the approach of professional services would lead, help our team get up to speed, and then during the transition, we would flip, and we would lead, and they would assist, which is exactly what we did. And then long-term, living with managed services to help us be able to cost arbitrage some of the mundane patching and the like, and then partnering with them to create a patchwork of support around the globe 24/7, 365, which is what we have in place today. And then we wanted to push limits, right? Anybody who works in our organization knows we like to go fast. We like to innovate, we like to experiment, and then ultimately we want to take what wins and get it to production as quickly as possible. And we do that in hopes of creating an uncommon client experience, especially for clients of logistics providers who historically have not innovated as quickly as other verticals. And some of that includes real-time visibility, predictive optimization, human-in-the-loop workflows. Again, I'm going to keep hearkening back to that because for us, you saw the complexity. There's just a lot that is between the ears of people who are specialists around the globe, who know local regulations, who know the carrier bases that needs to be leveraged. And so we attempt to keep humans in the loop at every step in the process. And then we absolutely had to have global scalability. Like I said, we operate in multiple countries around the globe, over 150 offices. So it was really, really important for us to be able to scale out globally. Okay, execution strategy. I'm just going to pull these up so that you guys can see those as we go through. But automation. We took an engineering first approach. This was not lift and shift. We wanted to eliminate all of our click ops, all of them, right? And really, the reason why is so that we can have certainty as we move fast, as we deploy. We have a way to orchestrate deployment, and then we have a way to quickly recover in the event that we made a mistake, which is inevitable, it happens. Reliability, uptime, uptime, uptime. We're now judged just like a lot of other solution providers, SaaS companies. We have uptime SLAs with our clients for things like our APIs, our reporting. So we had to make certain that we could meet those uptime requirements. And then scalability. We talked a little bit about load. I'll just give you a for instance that might resonate. When we're ramping up to Christmas season, right, there's a lot of goods that come into the United States. And so in August, you'll see a huge peak, right? We have to be able to manage that peak. And it's different for the different cycles for different industries. Business continuity. Absolutely had to make certain that we could hit our RPOs and RTOs, and that we tested those and proved that we could hit them, not just on paper. And then modernization, obviously. Where we could, we want to make things more simpler, and we want to make things more resilient using serverless compute. And then latency. Latency is a big one for us. Akil will go into some of the latency requirements. Just like a lot of you guys, I'm sure we have vendor applications. Some can handle latency better than others, and some have very strict latency requirements that we had to adhere to. So with that, I'm going to turn it over to Akil.
Thank you, Brandon, for that overview of how you came up with the strategy for our team. So the way we got started with Crane is we took what was Brandon's vision and Crane's vision of the migration strategy. We started working backwards with them. The reason them being on stage today is some of the simplification and efficiencies that Crane achieved that you can take back to your own environments and apply them as well. So we thought it is valuable for us to share this information today. So let's dive in. So working backwards from Crane objectives, we brought with 4 principles that were very key in the way that we have designed the migration. We started off by deciding that Crane would require a foundational environment with landing zone. But a lot of customers, when we work with proposing landing zone, the usual pushback we get is there is an impression that it is always a trade-off between security and agility for teams. Am I going to create a more secure foundational environment where now my developers are restricted that they cannot move fast enough? That is not the case. You will see that in the way how Crane was able to adopt landing zone, but still was able to be flexible enough to use some of the partner solutions that they were working with. They wanted to operate in 3 different clouds, but still wanted a simple design. So that's one of the major objectives that we went back when we actually designed their architecture. They wanted to move into AWS, but wanted to move along with AWS while their team is getting trained. So how did we pace that? How did we train their team? And how they are leading some of those initiatives are interesting for you to learn as well. And modernization, like Brandon mentioned, how do we not just migrate and leave? How do we keep continuously modernizing so they're future ready for scalability and what's coming in their business? So the overall migration approach started off by the AWS professional services team partnering up with AWS solution architects and some of the specialist SAs that we have. We went in and we tried to discover what is the lay of the land for Crane. What is their landscape? What is their consumption today, which translated into a cost analysis of what are they spending right now. Because when we are moving from cloud to cloud, usually the cost is not a huge factor in savings, but you are not comparing apples to apples. So we would often go back to this cost analysis throughout the migration saying, are we proposing the right solution for them? Are we making things better? Are we moving them to a more expensive solution, whether it is compute, database, or other things? During the same period, we have also handled executive visioning sessions with Crane team, so that the executive alignment is in place, and we also had trained technical teams from Crane as well, so they are along in the journey of this migration. So we went on to actually mobilize some of the workloads, which is where we started to plan. So the planning phase started off by actually designing their landing zone environment, creating an operating model, understanding how Crane operates in cloud today, and sort of also visioning how they would operate post-migration as well. So then the actual migration kicked off. If you see the parallel lines up there, those parallel lines mean those are different waves. We didn't just take a big bang approach of moving everything all at a time, we started picking each application, building portfolio for that application, what are the dependencies involved, complexities involved before we started moving applications. So that helped us take the learnings from each application and take those learnings and efficiencies into the next one, so we are doing it more and more efficiently as we progress. And post-migration, we also optimized some of those applications, and we continue to modernize them today. So this is their landing zone environment, right? So they have a typical architecture of control plane of management account sitting on the top, orchestrating multi-account design, enabling creating accounts. They have aggregated backups, audit logging, etc. But what the flexibility part comes here. Crane wanted a centralized firewall control plane where they control firewall for all the traffic. We were able to achieve that and put that into the design. And the whole infrastructure as code foundation for post-migration was based off of how well we implement landing zone. So this was very critical for us to implement. So yeah, in the same process, we had used automation for any security configuration remediations as well. So any changes to configuration and security aspects were all remediated with automation. At the end of the implementation, what we were able to achieve is a one-stop shop for Crane teams to deploy accounts with a baseline accounts created. A dev team or a data engineering team wants to create an account. They have a base account structured with all the security and governing policies that are applied to it, so their security posture stays standard over a period of time. So let me walk you through some of the simplicities that we achieved. Usually customers, when they try to implement cloud migrations in AWS, they at least operate in 2 regions. So the way we set up connectivity between regions and VPCs is you connect every VPC in each region to a transit gateway so that the VPCs can talk to each other. Now you're trying to connect 2 regions together, and then we would set up a transit gateway peering. And then now the customers have an on-premise environment or another cloud environment. We use direct connect for these peering connections to connect with, so they can connect to those things. Then we learned Crane operates in 6 different regions. Now we were talking about transit gateway connections in each region, peering connections between them. The fun thing is transit gateway, the routing between those transit gateways look like this if we had implemented this. This moved away from the principle, directive that we got from Brandon's team is we wanted a simple environment. This doesn't look simple to me. So that's where we took a step back. We went to a drawing board, like how do we implement a multi-cloud architecture design that is still simple enough that they can actually operate at scale. That's when we started looking. AWS had come up around the same time with a service called Cloud WAN. This is a global managed WAN network service that we have, where you can connect networks from different regions seamlessly without having to manage the routing between them. When you create Cloud WAN, we create what's called a core Cloud WAN network that spans across all the regions that you operate in, and we manage the connectivity between the VPCs that you put in that core network. Cloud WAN creates what's called a core edge network. CNE is what we call it. We put it in each region of where you operate. So every VPC that connects into that CNE can connect to any other VPC that you put in that segment. Now, another thing that we learned when we started off the migration was Crane didn't have a proper network segmentation in their Azure network. So that's where the feature of Cloud WAN to use network segments came into picture. Let's say you have 6 production VPCs in 3 different regions. You can have one network segment. You can call it a prod network segment. You can connect all those VPCs into that segment. And now you have achieved not just connectivity between those VPCs, you also achieved the network segmentation that you would require. Now let me show you how we actually implemented this for Crane. When we started connecting 2 regions together, we would create a production segment. So every production VPC that is in those 2 regions now is connected through production segment. Now to the connectivity to Microsoft or on-premise, we would create a direct connect segment within Cloud WAN, where the production segment can now connect to this direct connect using direct connect segment. Now with that connectivity established, we can connect with Cloud WAN multiple regions into Azure environment to any subscription in a more simplified fashion. Now Crane operates in 6 regions. They added a new region or a new VPC. They just have to add those VPCs into the segment, and their connectivity is established without having to manage or update any routing tables for transit gateways or peering connections. So post that implementation, we found out, like Brandon mentioned, they had a lot of vendor-specific applications that required very low latency connection. So we realized they were connecting to Oracle Cloud, which was located in Phoenix, Arizona, and we didn't have an availability zone located there. How do we achieve a low latency connection if we don't have an availability zone in that region? That's where we started looking into local zones. So Phoenix had a local zone. So local zone is an area of presence that we have where we put compute, storage, and databases in most highly populated cities across the globe. So we picked a local zone that is much closer to Oracle, where the Oracle is sitting, and we were able to establish connectivity through direct connect into Oracle Cloud with fewer network hops. At post implementation, we were able to achieve latencies as low as 2 milliseconds across from AWS into Oracle Cloud. So the biggest takeaway for customers here is you can think about multi-cloud. The biggest pushback we get from executives when we talk about multi-cloud is it going to get too complex for me to manage? Am I, for the sake of being for the sake of being more flexible or having more choices between cloud, am I compromising performance? It's not really the case. You can still operate between multiple clouds, have a simplified networking and design architecture, have a foundational environment where you push automation in the way that you operate, and still be performant for your business. Now, let me show you how the Crane's posture looks today post-migration when we move the applications. So every application that we moved with that foundational environment now operates, has regional resiliency, that every workload now can fail over between availability zones in that same region. And they also have the ability to spin up or bring the same application back up in another region if at all a region has to go down. We use services like Elastic Disaster Recovery to replicate most of all the critical applications, and we use Terraform for any application to be spin up for infrastructure or core deployments. So post-migration, Brandon spoke about time to market. How do we make Crane's team more efficient so that their time to market has improved? It comes from 2 factors, right? How fast can they how fast can they deliver new features to their business? That comes from how well they're governed between teams. How fast can they take a business outcome from their business, deploy the infrastructure that is required, develop the code, and how do they push it fast enough? I think automating all of their both infrastructure and code deployment process into one repository now enables them to act fast and serve their customers much faster. So far, we have discussed the way that they have migrated. Now they are in AWS. How did they approach migration? Most customers who are new to AWS, Crane was a customer who was new to AWS. When we work with them, we usually do a lift and shift. Let's take everything that you have, let's put it in AWS, and let's think about modernization after. Brandon's directive to us was, we need you to rethink everything that you move over. We need you to re-platform. We need IAC, we need automation. We don't want you to move us from a VM to another VM without adding value to us. They wanted value from day one. So that's where we took every application that was forced from vendors, vendor-specific applications. We re-platformed with automation, moved them onto AWS. Now, the kicker is when Brandon mentioned about how we wanted to flip the team around where his team takes more lead and AWS takes backseat at a point. That's where the refactoring, the time where we started refactoring, that's where we have seen the shift. Crane team came back to us and said, we don't want you guys doing all the work anymore. We got trained, we have teams now that are upskilled, they understand the environment better. For any applications that Crane has built natively within their business, that they want to move to more modern cloud-native applications on AWS, they wanted to do it themselves, and they just wanted AWS to be there to just guiding them. So think about a cloud-native application built on Azure. Even if they were using managed services for databases, they would still want to move into a managed service on AWS, but wanted to use services like serverless, and B, move off of SQL and even move towards PostgreSQL and have options like global scaling enabled now. So Crane team, as we have seen, have shifted from where we were leading some of the migration initiatives. Now they are designing how they want to move those workloads, and also we're picking and taking our advisory during the process, and have really transformed the way they're operating in cloud now. At the end of it, what you see now is Crane operating more than 2,500 distinct AWS resources with over 34,000 of Terraform code written for them, and over 150 modules within Terraform built to manage their environment. A foundational shift in the way they were operating in Azure towards in AWS, where they have taken automation as their automation focus as they moved any workloads after. Now they didn't stop there. They started looking more things that they can innovate, that can power from this migration. I think Rusty now will walk us through what are some of the forward-looking outcomes they're working with us. Rusty.
Thanks, Akil. Okay, so vision ahead. So Brandon and Akil have talked to you about a lot of the architecture and what Brandon, what he wanted to do and how we brought that to AWS. So you know a lot about that so far, but let me just say this. I've known Crane for about a year and a half or so, and I can tell you one thing, they do not stand still. So these couple of things that we'll talk about, we've only got time to highlight a couple, but let's go over what they're going to build next. So Brandon mentioned some of this in his opening, but the third-party logistics industry is just full of challenges. The complexities. So all of these complexities we looked at and we said, hey, how can we go tackle some of these complexities, solve some of these really important problems? So I'm going to summarize just a few of them here about what we went as our direction to start solving. So the first thing is communications velocity. So Crane is just constantly talking with customers, brokers, warehouses, operators, and drivers, and all that constant communication creates dozens of messages for each product that gets shipped. Second, there's challenges with predicting deliveries. Yes, Crane can tell you where your shipment is today, but customers want to know, when is it going to arrive, and can I start looking out into the future like Brandon talked about? So third, and this one's really important, Crane operates warehouses globally. And if you think about what they have to do, they've got to staff warehouses efficiently. If they don't have enough, then you're going to start creating bottlenecks for shipments that are coming through their pipeline. But if they staff them too much, then you're burning people and burning the staff, unfortunately, and you're just wasting money. So we wanted to make sure we talked about warehouses too. And then finally, just again, the last one I wanted to highlight is just manual processes. So Crane teams are just constantly manually verifying documents, cross-referencing data between systems, making phone calls to confirm. And what is that? That's really just not a lot of value add in those particular activities, but they're really necessary friction that slows everything down and introduces human error. So Brandon and his team realized that they wanted to take a crack at this, so that's where we came in with agentic AI. So I'm going to just very briefly talk to you about a few of the AI agents that we are starting to build with Crane. So number one, the booking agent. So the booking agent handles the entire ordering process, capturing requirements, checking capacity, and confirming the order in seconds. Second, the locator agent. So the locator agent proactively monitors every shipment in real time, answering the "where's my shipment" question in seconds. The exceptions agent. So the exceptions agent instantly identifies issues and either resolves them autonomously or sends with context information for a human to make a decision on. So this is one that Brandon's real passionate about, and exceptions handling is a really big industry-wide issue that we're hoping to solve with agentic AI. So next is predictor agent. So predictor agents will analyze historical data, current conditions to forecast delay in a particular shipment. And then next, the negotiator agent. So this handles carrier negotiation by analyzing market conditions, historical performance, and capacity to secure optimal pricing 24/7. So really important to understand, this is just 5 of the particular agents that we've got identified now, but with Amazon Bedrock and Bedrock Agent Core, we can see Crane adopting AI agents across every part of their business. So there's not enough time in this particular session to do a dive deep into their AI strategy, but I want to share with you the 3 particular areas that we focused on. Number 1, we're focused on establishing secure government access to foundation models through Amazon Bedrock. So this is absolutely critical because Crane operates in a highly regulated industry with sensitive documents, and we couldn't have a Wild West approach to AI. Also, Amazon Bedrock provides Crane with API access to foundation models without managing any infrastructure. More importantly, it gives them enterprise-grade governance. Second, we are building and deploying AI agents securely and at scale with a quick path to production. This is where Bedrock Agent Core has been really transformative for us. We can take a new use case, prototype an agent, test it with real data, and deploy it to production quickly. And that's been game changers for us in Crane. And last, and this one's really important, and was really just transformational for us as we started talking about AI, is we have to use the data that's there from Crane today. So Crane has decades of operational systems, things like transportation management systems, or TMSs, warehouse management systems, or WMSs. I've learned that. I thank you all for teaching me those terms. Customs platforms, carrier APIs, and customer portals. So short story is we couldn't rip and replace all that stuff. These are their systems of records, and they work. And we wouldn't want to rip and replace them anyway. But the key part is our AI agentic solution had to work with their existing platform. So that was a must. So this is the agentic AI, sort of call it our architecture that we're planning moving forward. So starting over at the left is the front-end applications layer. This is where users will actually interact with AI agents. In the center there in the box is Amazon Bedrock Agent Core. So this is where the intelligence will be, where the AI agents actually operate. Moving over to the right is between the Agent Core and the data layer. It's where we're building a critical integration tier, the Agent Core gateway, MCP servers, and custom tools. And then if I could direct your attention all the way over to the right is that data layer that we talked about just a minute ago. So that's existing data systems integration. So systems that have been running Crane's business for years. So things like TMS, WMS, financial systems. So these are the systems of record, and they'll continue to operate just as they do. So if there's one thing I could encourage you to take away, so our architectural principles here are we're not replacing these systems at all. We're augmenting them with intelligence. The data will flow up through the integration layer, get processed by our agents, and insights will flow back. So what you're looking at here is our agentic AI roadmap for Crane. So the last innovation that I wanted to bring up here before we close out is, has anybody seen anything on Amazon Leo this week? So this is really exciting for us at AWS, and it goes beyond software and AI. So one of the fundamental challenges in global logistics is connectivity. Crane operates warehouses, distribution centers all over the world in a lot of remote locations. So traditional internet connectivity sometimes just isn't available. Sometimes it's really expensive, or sometimes it's just not really good. So that's why we're planning to leverage Amazon Leo, AWS's satellite constellation. It's going to fundamentally change how we think about connectivity for Crane. So there's really 4 areas that Crane is going to focus on with Amazon Leo. So first and foremost, business continuity is kind of an important thing for a company like Crane. So reliable internet that allows them to establish robust backup and recovery systems. So that's kind of first and foremost with Amazon Leo. Second, weather-resistant connectivity during storms and severe weather events. And for a logistics company like Crane, that's really, really critical. And then last, Amazon Leo provides comprehensive network redundancy. So with enterprise architecture best practices, and Crane does this, they build in redundancy all along the way. So redundant servers, multiple availability zones in AWS, diverse network paths. So Amazon Leo will now be part of their redundancy strategy. So it's not just another connectivity option for Crane, it's really a strategic enabler for them. So it ensures business continuity, direct cloud connectivity as well. So I'll talk a little bit about direct-to-cloud connectivity with Amazon Leo. This is really an architecturally significant thing for customers, including Crane. So when remote sites connect to AWS, traffic typically flows through the public internet, multiple ISPs, internet exchanges, and network hops. So what does that do? It's going to create latency, potential security vulnerabilities. So Amazon Leo will change this. Lower latency means that applications that are in remote areas will perform just as fast as those that are in their Houston headquarters. So it's going to be a real game changer for them. So remote sites will become extensions of AWS cloud infrastructure. So again, if we're implementing, or as we implement AI, then those AI agents can perform just as well at a remote location as they do in a major metro area. So the last thing is, Leo really is going to provide cloud-grade connectivity to places where it's never existed before. So we're excited about their plans with Amazon Leo. So here I'm going to pass it back to Brandon, and he's going to give us a summary of all the innovations and the measurements that his team undertook on this move to AWS. So Brandon?
Sure. Thanks, Rusty. So we have a rule in our organization: if you can't measure it, you can't manage it, and it probably didn't happen. So we like stats, we like data, so I'll just throw a few things up for you here. We talked about moving fast, right? So we estimate that we've increased our capability to deploy by about 70%, largely because we've taken a lot of ClickOps out of deployment pipelines, right? So we kind of estimate over 10,000 operations have been automated. So now we're in a position where we feel confident with deployments, at least more confident than we did before. This was never about cost, although I said we want to be good stewards of our resources. So we ended up being about net neutral, even with the multi-cloud implementation, which is a testament to the AWS team and the design that they helped us come up with. And from a performance standpoint, we talked about this, but we measure our latency. So sub 2 millisecond latency for a cross-cloud solution is pretty good. So we feel pretty confident about that. And then from a security standpoint, we measure drift now between what we actually have deployed and what our Terraform models say should be deployed. And so we can manage drift, which helps us feel a lot more resilient in our ability to be able to push changes quickly, and know that from a security standpoint, no one's opened a door or window that we don't know about and don't have sight on. So with that, I will turn it back over to Rusty.
Okay, so we just wanted to finish the session off with a few questions. So Brandon, I've got one for you. So undertaking a multi-cloud migration, kind of, maybe it didn't keep you up at night, but maybe talk us through, sort of your mindset in going into a multi-cloud migration with AWS.
Well, it did keep me up at night at first. But it was really about getting to know the AWS organization, having confidence in our ability to upskill our staff, and you guys helping us create a training plan, and not only for our staff to be able to learn new skills, but then also to help them be hands-on as we transition from AWS leading the effort to our teams leading the effort. And we feel very, very confident in our posture now. So I think that was probably more than anything. Look, the technical things we could work out. The cost we could work out. But really having a firm foundation that we felt really confident moving forward that we could administer largely ourselves was really, really important.
Yeah, awesome. Thank you for that. And I do see some of the Crane folks, folks on Brandon's team out in the audience. And I do have to say, we couldn't have done it without you. So thanks for all your help. Akil, how about you? Any questions for Brandon?
Yeah. So Brandon, you work with multiple cloud providers.
Yep.
Probably wide variety of tech teams.
Yep.
What stood out with the AWS tech team that you worked with?
I think it's the partnership. Like I said, the DNA between our teams is very, very similar. You guys are very entrepreneurial. You come up with ideas like you talked about with the VPC connections for our backup to OCI and the latency that we needed to hit. So thinking outside the box, staying on task, measuring everything, moving very, very quickly, and then keeping the goal in mind. It wasn't just a lift and shift conversion. We wanted to take this opportunity to create an environment that was more resilient, more scalable, that we felt confident moving forward in. And you guys, the partnership there, I couldn't have asked for anything better.
Awesome. Thank you, Brandon. Okay, so that ends our session. We will be around here if you have any questions, but have a good rest of reInvent. Thank you.